right, so we're going to close out on chapter 9 by discussing the whole concept of reaction yield. Now, let me open this up first. Okay, so let's talk about what we have been doing so far. What we have been doing so far is calculating, for the most part, the amount of product you expect to get from a reaction given the amount of reactants. Now, those amounts that we calculated, we were assuming that basically we're getting the maximum possible amount of product based on our stoichiometric calculations. All right. However, in practice, that is not the case. It is very, very unusual for us to end up with basically the reactants forming the maximum amount of product you expect to get, right? So sometimes you might end up with a less than 100% yield of your product. And there are a couple of reasons why that happens. One reason is that you can have the possibility of side reactions taking place. So therefore, the reactants that you start off with can form the product that you expect to get, but can also form other products. Another reason is that many reactions are reversible. In other words, the product may form, but the product itself may react to reform the original reactants that you started off with. So those are the two main reasons why many reactions fail to give a 100% yield of product. So therefore, we have to now talk about the difference between what is known as the theoretical yield and what is known as the actual yield. So the theoretical yield of a reaction, as stated here, is basically the calculated amount of product that one would expect to get from a given amount of reactant. All right, that's the theoretical yield. So what we have been calculating in the previous examples when we were doing those calculations to determine how much product we expect to get, that amount was the theoretical yield. In practice, we won't get that. In fact, what we will get in practice is what is known as the actual yield, which, as the name suggests, is the amount of product you would get directly from the experiment. All right, so if you perform the experiment, get your product, and you weigh it, what you end up with is the actual yield. Now, ideally, the actual yield should be equal to the theoretical yield, but as I said before, because of a couple of reasons that I mentioned before, that is not the case. In most cases, you're going to end up with an actual yield less than the theoretical yield. All right, so that brings us to the third terminology that you need to know, which basically relates the two. It relates the actual yield to the theoretical yield, and that is called the percent yield. So the percent yield is basically the actual yield divided by the theoretical yield times 100%, right? And it is a measure of how successful the reaction is, because of course you'd like to get 100% yield, but you in most cases you won't. If you're doing 90% yield, in fact, you're doing pretty good. Most reactions, their percent yields are like in the 70s and below. All right, so that's the difference between the actual yield, the theoretical yield, and the percent yield. So we're going to look at an example here of how we can determine the percent yield of a reaction. So again, it's dealing with the same equation, the reaction between silver bromide, or actually magnesium bromide and silver nitrate to form silver bromide. So let me just rewrite the equation here. Whoops. Let me use a black ink this time. And okay, so the equation is, I'm sorry, let me do this again. So the equation is, let me go here, MgBr2, whoops, this pen, MgBr2 plus AgNO3, and we're going to need a 2 here, and the products would be MgNO3 squared plus AgBr, and we're going to need a 2 here. So that's a balanced equation, right? So in this question, they gave us 200.0 grams of magnesium bromide, right? Now you'll notice the way the question is worded, it says the question says, and an adequate amount of silver nitrate. So what that tells us is that it is the silver nitrate that's the excess reactant, and the magnesium bromide that would be the limiting reactant. So basically, the magnesium bromide is what determines the theoretical yield. So we have to convert that to moles. So you're going to have 1 moles of MgBr2, Br2, and down here the molar mass of magnesium bromide, which is MgBr2. And according to my calculation, that's 184.11. So let me write that here, 184.11 grams of MgBr2. And then we look at the mole ratio between magnesium bromide and the silver bromide. It's a 2-to-1 ratio, so we're going to have 2 moles of AgBr above, 1 mole of MgBr2 below, and then we're going to calculate the mass in grams. So we're going to have 1 mole of AgBr below, and the molar mass of silver bromide above, which is 187.77 grams of AgBr, and you work that out. So let me do that calculation here. 200 divided by 184.11 times 2 times 187.77, and according to my calculation, this works out to be equal to 408 grams. 408 grams of silver bromide, AgBr. So this is the theoretical yield. So to get the percent yield would be equal to the actual yield, which is given above here, the 375.0 grams, 375.0 grams over 408 grams, which is the theoretical yield. And you work that out, 375 divided by 408 times 100, and according to my calculation, this works out to be equal to 91.9%, which is pretty good as far as percent yields go. And of course, I think this should go without saying, but let me say it anyway. The maximum value, of course, for percent yield would be 100%, of course, and therefore if you do your calculations and you end up with more than 100% yield, that means something is wrong with your calculations or something is wrong with the data. All right, so that's basically a typical percent yield type problem that you could encounter. All right. Okay, so that's basically it for chapter 9. So the next video will be starting with chapter 10, which deals with heat and heat energy and all of that. All right, so until next time.